Mongolian Ger by the lattice Boltzmann. Okay.
Hello everybody. First, I would like to express my sincere gratitude to organizing committee and scientific committee of this conference for accepting our paper here. Today I'm going to talk about an elementary flow and heat analysis of Mongolian Ger by lattice Boltzmann method. With this presentation, I will describe motivation and research importance, and I will give you a brief introduction to the lattice Boltzmann method for fluid flow and heat transfer, and then we will see the development of numerical model and numerical analysis of Mongolian Ger with the discussions, and then we can do conclusions with future works. So Ger is a fundamental motivation of this study. Not only the Ger, we need to study every traditional thing in a deep, advanced scientific way. Unfortunately, the flow and heat inside the Ger is a new topic and it is never studied before. And the second motivation is air pollution. We know the Ger and Ger district is the main source of the air pollution. But we are just wandering around it because we don't know how to solve it. And the third motivation is the heating technique of the Ger and the houses. So, you know, we spend millions, almost billions of rupees for it, but in the last 15 years, that shows we need good, stable research for it. By studying flow and heat transfer inside the Ger, we can get full understanding of thermodynamics in the Ger, and subsequently we may find a solution to improve heating of the Ger and to innovate the Ger. And consequently, of course, we can reduce air pollution at a certain degree, and all outcomes and success with this kind of research is beneficial not only to city developers but also for the nomads. Of course, nomads want to have a wonderful and comfort Ger. So let me introduce lattice Boltzmann method on the scales. This scale is based on the Kurz number, which is the ratio between mean free fat of molecules to the characteristic length of the problem. And there are three scales, as I said, and they are macroscopic scale and mesoscopic scale and microscopic scale. We know the macroscopic scale because we live here and we touch, we can see this scale. And we also know microscopic scale, this is the nature of the molecules. So between these two scales, we have mesoscopic scale, and in this scale, flow and heat transfer is governed by Boltzmann equation only. But in macroscopic scale, we need Navier-Stokes equation and heat equation to solve heat and flow. So we deal with this scale because this has some advantages and simple to solve the flow and heat transfer. So of course, in Navier-Stokes equation and heat equation, and the Boltzmann equation has some connection, and we can draw this connection with the dimensional analysis. So simply, lattice Boltzmann method is lattice Boltzmann method solves discretized Boltzmann equation on the lattices. Here we have two equations for the fluid flow and scalar field, and here we have determination of the velocity and temperature. Temperature gives force, buoyancy force. Force induces velocity, and velocity carry the heat. This is how heat transferring inside in the fluid. So based on the lattice Boltzmann method, I have developed several codes. For example, this one is the main program of the code to compute flow and heat transfer inside the Ger. To validate this code, I just solved the convection diffusion problem and the Stokes second problem. This is the result of the convection diffusion problem by finite difference method and the lattice Boltzmann method. And this one is the result of this Stokes second problem, also solved by finite difference method and lattice Boltzmann method. And generally, I can say that the lattice Boltzmann method gives a very accurate result, and that's why researchers and a lot of people love to use it. So let's get started numerical analysis of Mongolian Ger. So we are going to study heat and flow analysis, flow inside the empty Ger with 5 lattices, because this is a common size of the Ger. And we do non-dimensional analysis because this is more appropriate for the basic and fundamental implications. And here, this is great, and some parameters for computation. And the important thing is we solve two situations that are the Ger gets cooled from the warm condition, and second one is the Ger get warm from the cold condition. So in the simulation, I assume that the inner surface of the Ger is well insulated, and only crown and the door is uninsulated. And we place a stove in center of the Ger as usual, and this stove is ordinary stove, and this is the computational domain we have. So this is a result, the Ger cooling down from the warm condition. That means the temperature, initial temperature is 1. This is normalized temperature. And the pictures in the first row show the temperature distribution inside the Ger, and in the below show the streamlines in the Ger. And we can see the door lose heat active than the crown. Ironically, this is why dog love to lie in front of the door in winter time. Some of we saw it many times, but we don't know why dog lie there. So, and this is an animation showing how Ger gets cooled down from the warm condition. So let the dog lie there. So from this, we can see the door and the crown starts to lose heat, and soon after the warm air and cold air starts convection flow inside, and then we can see one big circulation here. And with this simulation, we found that the Ger gets cooled down uniformly at Fourier number of 0.062. This Fourier number is indication of the time. And this one is the result of Ger heats up from the cold condition. That means the initial temperature was 0 cold, and the stove generates heat, and first heat transfer by conduction and then convection. In the result of convection, we can see the mushroom-shaped heat transfer, and it grows as heat transfer through the Ger, and we can see center placed stove. With the center placed stove, we can see 2 circulation cells inside the Ger when the Ger gets heat. So this is the result how Ger heats from the cold condition. Also, we found that the Ger gets heat up uniformly at Fourier number of 0.045, and newly generated heat from the stove goes up to the crown, and before gets to 2 sides as the cup of the mushroom extends 2 sides. So based on the simulation, we do an elementary explanation of flow structure when Ger gets cooled down, and then when Ger heats up. When the Ger cools down, we can see one big circulation, and then after we can see the small circulation, but this small circulation is innervated by the big circulation eventually. And but and the gear hits up, we could see the big two circulation. This two circulation is very stable, and it lasts until the gear hits up. So I would like to do some discussions with this research. The basic characteristic of the flow and heat transfer inside the gear are disclosed, but not fully. We only do two-dimensional simulation, so we need to do three-dimensional simulation. And the research proves that the location of the uninsulated parts that are crown and door, and they still are naturally optimized in the gear. This is the wonderful side of the gear, we know, and we found that the door should receive some improvements rather than the crown, because door lost heat rather than the crown, even though the door and crown have some same area of the heat loss. And that's why this idea brings vacuum type door and crown. So, and then to get warm quickly, the forced convection flow is needed inside the gear. This is maybe a design constraint for the new heating equipment. And then I want to stress some novel and innovative part of this research. In respect to the model is applicable to the heat analysis of any type of room and optimization of the heating equipment and its location. The researchers attempt to study gear with an advanced scientific approach, and this is the very first study of the heat transfer inside the gear. And this research is the scientific contribution to reduce indoor and outdoor air pollution. And this is also a solution to avoid from any costly experimentations. And more importantly, this is an initiative of some innovative ideas to strengthen the gear partially or fully. And we came to the conclusion. The paper formulated the two-dimensional numerical model by lattice Boltzmann method for flow and heat analysis in the gear. We defined the distinctive characteristic of the natural connection flow and heat transfer inside the gear when the gear gets heat up and get cold. And I believe that the elementary knowledge of flow and heat transfer inside the gear, which we discussed, will help to develop effective and energy-saving heating system in the gear. And in the last day, I found that the time the gear gets cooled was nearly 1.4 times slower than the gear gets warm. This is the indication that why gear gets heat up very quickly. So, and I want to list some future workers. We need to do three-dimensional numerical modeling of the gear, including furniture as possible, the member of the family, the man and wife and husband. And I would like to do 24-hour simulation with heating and cooling in winter time, and it is important to test some type of stoves and heating equipment to optimize it. With this regard, I will show you one example in the next slide, and this is also important to test highly insulated door and crowns, which we developed the idea for it. And I would like to extend the model to indoor air quality model and to apply it to the important facilities like rooms in hospital or in kindergarten. So I said that to get warm quickly, we need forced convection, and then I thought maybe it is possible to blow warm air parallel to the floor from the stove. So this is the special stove I just imaging. So this is how this stove works, and we have 3 fingers and 2 of which is mushroom, and then but eventually becomes one bigger mushroom. And this simple simulation drives two ideas. The first one is the blowing velocity must be much higher than the conversion velocity to be effective heater. If we design the heater like blowing air to the pellet to the floor. And second one is a new idea. That one is that they still can blow air to the crown. This will accelerate the velocity of the convection, and then we can reduce the time to the gear gets cold. So, and thank you for your kind attention. If you are interested in my research, please visit my academic page on the ResearchGate and Google Scholar.
Okay, thank you very much. Questions, comments?